Alright YouTube, back again, trying to slow the smart meter with solar panels. Now I got 8 230 watt panels, okay, and they're roughly 5 by 3. Okay, I got my project manager on site to make sure I do this right. This is a model of my rack, okay, it's not what's going on the roof. Okay, the metal is going on the roof. Now that's expensive, so if I make a mistake, I'd rather make it on wood. So I'm making a little model to figure out the best design. Now there's a couple ways you can make a rack. You can mount them all solid if you want, or if you want them to track the sun, you're gonna have to worry about wind. Okay, if you put 4 together and make the whole big panel track, well, you're gonna have a problem with wind, ripping them off your roof or wherever you have them mounted. So to get around that, I will have them mounted individually, tracking the sun. Back there is a cutout of how big my solar panel actually is. Now if you can imagine this here being the solar panel on top, and of course it'll come out, but this is just like a silhouette. Okay, and I have it pivoting in the center. Okay, and when I pivot it, I don't quite get 45 degrees. Okay, I'd like to get a little more, like say maybe 60. The problem with that is the top of the east panel here will be blocking the sun on the west panel in the morning. Okay, well, how do you get around that? It'd be nice if we could get, when it turns, this east panel to drop and this west panel to rise. So what I'm going to do is I'm going to change the pivot point from the center, okay, to the inside of each panel bracket, and I'll show you what happens. Okay, now the pivot point has changed, and you'll see what happens when I move this to the east. Okay, can you see that? The west panel is higher than the east panel. The problem now is the angle is different. Okay, well, that's the next problem. It's a pivot point on our bracket. This is going to be angle iron, but down here is where it pivots. If we had a brace that ran down here directly under this one, they should have the same angle when you turn them. Alright, let's see if that works. Okay, now I got my bottom pivot point changed on both sides. Both are on the inside, cutting in. Okay, let's tilt her up. See what happens. Okay, as you can see, okay, that one's much higher. The angle is almost the same. I did this real quick, so nothing's exact. And we have more than 45 degrees. More than, which is nice. One problem is, if you notice down here, is the panel would actually be hitting this connecting link. So what I'll have to do is I'll have to drop it down. This will have to be lower so it don't hit. But I think it's going to work out nicely. Alright, I'll rework it a little bit and show you what I come up with. Okay, real quick, I'll show you the changes I made. Alright, instead of moving these further away from each other, I actually moved the pivot point up to here. Okay, I made this longer, like I said I was going to, and I made this pivot point perpendicular with this one. Alright, now let's say the sun is coming out towards the east. That's the east panel, where it's going to be. It would move like this. Let me block it up so it don't fall. Okay, there you go. That's what it looks like. Each panel is approximately 55 degrees. Okay, you'll see the east one almost touches the ground. So with this height, this is the best I'm gonna probably be able to get it, I'm thinking. But you'll notice actually how much higher that west panel is compared to the east panel. Now let's say the sun sets. All right. All right, there's sun setting position. All right, same thing here. This works perfectly. This ought to catch a lot of sun and give the solar panels its full potential. I mean, the best we could do anyway. But the only other thing I have to do, which I will be making something, it'll be manual, is this has got a tilt for the position of the sun during the year. So this is a pretty good design, and I think it'll work the best for me. I'll start cutting up this metal to actually make the rack now that I know how the layout has to be, and that'll be part 2. Alright, I redid this so it's more to scale, more measured out. The cutouts represent the angle iron that's going to be on there, but the right panel is 1 foot higher than the left panel. That's when it's tilted straight flat. They are about a panel width apart. And again, there's a shot of it with the sun going down. Once again, east panel is now a foot higher than the west panel.